Welcome to FPGA 2023. And we're your panel tonight. And we're lucky to have a number of different people up here. Farthest from me is Vaughn Betz, professor at University of Toronto. Next to him, continuing our professor cluster, is Pierre Emmanuel Gaillardon, who is at the University of Utah. And then we have Chris Lavin from AMD and Ted Speers from Microchip, a company whose previous incarnation I worked with at a long time ago. And I'm Dana Howe from Rapid Silicon. And so we're going to be talking tonight about open source and its interactions with FPGAs, but software, hardware, or hopefully both. And just to kind of set the stage, open source has been a factor in many different ways, even before it had that name. So you may remember that the internet had RFCs, and the internet essentially had an open source process at the beginning. And now we have thousands of open source RFCs. And then what happened is that Richard Stallman became frustrated that he could not change the software in a laser printer. And now we have GCC and the GNU public license and a lot of other developments, including Linux, all downstream from that. Now, in hardware, sort of our immediate predecessors, we had university processor projects. I personally clearly remember Berkeley RISC. More recently, we've had RISC-V. We have chiplet projects like UCIe. Now, since the end of the 90s in FPGAs, we've had essentially open source projects like VTR, F4PGA, and now OpenFPGA. Now, each of these projects and their communities continues to grow. And so we're wondering in what extent and in what ways will these influence future FPGA development, whether in the hardware or software spaces. And so let me just point out one thing, perhaps an opening question. GCC itself has been under development now for 35 years. And it is one of the standards of compiler development. Parallel to it, we still have many commercial compilers, which are still actively developed and promoted. Now, when we look inside our space with Verilator and Yosis and VTR and F4 FPGA and other tools, do we think we're on a similar path? And will we get there before retirement gets us? And let me open first to Vaughn, since he's farthest away from me.
I'm closest to retirement. Well, that's dependent on my retirement date, which is dependent on my teaching reviews and how many complaints students make about me. So there's a degree of uncertainty there. And I think your analogy to G++ and how it's coexisted with commercial compilers is very apt. I think that's what we're headed for. I'm excited to see that open source is gaining momentum in our community. But there's an enormous investment in hardware and in closed source CAD systems that is not going to go away anytime soon. But I do see that as the maturity and the capabilities of the open source tools grow, they don't have to have exactly the same feature set or optimization quality as Vivado and Quartus and the other commercial CAD systems. What they're doing is basically reducing the barrier to entry for novel devices, right? If you are someone who is thinking, I will make hardware that is exactly like what AMD is making, but I'll do it better, that's probably not a great idea. But if you have ideas of how it's going to be different, how it's going to go into a larger system, the barrier to entry has been greatly reduced by open source software and now open source hardware generators. So I think they're going to coexist, and I think it unlocks a lot of potential for innovation. And I think it's hard to predict how far it will go. I remember when Linux was first coming out,
yeah,
and Microsoft, clearly was not a fan, right? And they were the 2,000-pound gorilla that didn't want to open up Windows. And it would have been, I would not have predicted how far Linux came at that point. And I'm not saying we'll follow exactly the same trajectory, but as open source gains adherence, it builds its own momentum. Right. And that's, I guess, a key part of an open source community and open source project is how do you build that momentum? Because if you build it, it's a flywheel and you get stronger and stronger. And at some point, it actually is strong enough to have a really big impact. On the other hand, some projects just never build that, right? It can go the other way where they kind of fall behind. I can't exactly predict that, but I'd say at this point, we're at an interesting time where we have open source tools that certainly enable new innovation. But I don't expect them to, certainly supplant the state-of-the-art industrial tools.
Okay. So Ted, I got the sense that you'd like to see more open source usage than we've got right now. Do you want to elaborate on that a little bit?
Took the time to ask Chat GPT. You guys want to hear what really matters? But, yes, I believe we're on a similar path in the FPGA world. Open source tools such as Verilator, Yosis, others have been getting a lot of traction in recent years, yada, yada, yada. Nonetheless, the trend is clear. The growing community of FPGA designers, the increasing complexity of FPGA devices, the demand for flexible, accessible design tools are all factors that are driving the development of open source FPGA tools. I think that says it all. Actually, those of you who don't know, I'm on the board of directors of RISC-V International, and I think I've definitely played a role evangelizing that and making RISC-V what it is today. I mean, I think it's going to it's going to be the dominant ISA. I think unquestionably, and it's on a great growth trajectory. And the open FPGA tooling is something that has similar appeal to me for sure. Tim Ansell is not here with us today. I remember met him pretty early on in this process, and I've been pushing hard also to trying to figure out how to create the same magic for open source tooling for FPGAs. It's definitely I see the need to make it happen, want to figure out how to make it happen, but there's definitely some complexities that I've come across that I'll try and talk about as we go further today. But one thing I could say for sure, I attended the conference here last time we had in person, and have a panel up there, and everyone's saying we need tools, and you have people from Xilinx at the time and Intel just hearing this message. There's no way those tools are going to happen without some serious opening up of the FPGA. So the thing is, it's like a fire. You need oxygen, fuel, and heat, and for sure to create this conflagration. And for sure, open source tooling, if we want to create something bigger than we have today in the FPGAs, open source tooling is I don't know, it's the heat maybe.
So what I heard you mention in part was about current FPGAs in part opening up, and I'm wondering, Chris, do you want to elaborate on paths forward in terms of current FPGAs opening up?
Yeah. So I guess when we look at the scope of the challenge, right? We start with that GCC analogy. The effort it takes to convert your program into the thing working on silicon is a different kind of problem for a processor versus an FPGA. And I think the number of steps, I mean, they both have lots of research and development that has to happen in order for that process to take place. But I think we would all agree that FPGAs have kind of a higher step to get over that hump, to build those software tools, get them in place. And so these are really hard problems for humanity, right? And I think we all have this, many of us have this innate sense of like, we see what FPGAs can become. We know the silicon has some great potential. And despite industries dumping lots of, AMD's invested a lot in tools and everything, trying to make those tools meet those expectations, we still can imagine more. We can still see more on the frontier, and we want to get there. And I think we have this opportunity with open source to unlock some of that potential, to say, okay, FPGA vendors, they have to build tools that meet the needs of everyone. And, you know, that takes a lot of investment, that takes a lot of effort, and getting it all working right is a lot of work. But when you have your application, you're sitting down trying to build your solution, there's just, you can see that, oh, well, in my case, I want to do it this way, or I want to do it that way. Like Richard Stallman, I want the laser printer to do this or that. You want to be able to have that extra little control so you can, you know, exploit that optimization you can see right in front of you. And that is what I think open source can allow you to do. It gives you that freedom to go in and harness that power that's there right in front of you. And I think that's what's really exciting about open source.
And PE, you know, you've been recently working on Open FPGA, and I'm wondering, and so that fills a hole, but I'm wondering, you know, in light of what Chris is saying, what are the next holes to be filled beyond Open FPGA?
Well, this is a good question. There's just so much to do, right? But I think what is interesting is maybe not so much what kind of holes we could patch or fill, but what kind of new direction and new outcomes we could open, right? There is one thing that I think is important to consider with open source is as an educator, right? It's what it enables new people to get interested into a field, right? When I did my PhD, I used VPR at that time, and that really helped me, you know, dig into some code of Packers and understanding how things are happening under the hood, right? And I think our field strongly requires workforce, right? And people that are trained and motivated to work on challenging problems within our tools and within our technologies. So there is some clear education aspects that come also with open source tooling. Maybe one of the things we should do is not really filling in features, but expanding the use of these tools and training that goes around, and, you know, the outreach that is, you know, community building, and, you know, getting more people excited around open FPGAs, and then in the end, reducing the barrier of entries to FPGA, not only FPGA development, but FPGA use as well.
So just prior to this panel, we saw a paper that was nearly 20 years old, honored, and that paper was about, and think about, this paper came out 20 years ago. This was before RISC-V, and this paper was about how to add custom instructions to a processor. Now, we all know that within FPGAs, we're always, especially in a commercial environment, we're always presented with the question of, should we add a feature? You know, there are costs and benefits to adding a feature. What do we think about the possibility, and perhaps at some point, perhaps greater openness or flexibility of open source tools to enable what we saw in FPGAs in that paper from 20 years ago? And let me maybe take this first to Ted.
I'm trying to, what was the paper?
Oh, that was the one that was from 2004 about adding custom instructions
Okay, yeah,
to an established ISA.
Yeah, so I was thinking when you're talking about that, I was thinking of, you know, a successful open source example with RISC-V and FPGAs. We did.
That's why I went to you.
We did. I mean, we did run a contest. RISC-V Foundation ran a contest for doing, you know, cores, RISC-V cores in FPGAs. I think I was before the summit in 2019, and one of the winners is the core. I forget the name of the company. It's called Betz RISC-V. You saw it mentioned in the paper today. Yeah, spinal HDL. Yeah, and that thing is being adopted, you know, all over by a lot of companies. I think, you know, FNX is using that as part of their product line. So that's definitely a success of you know, RISC-V on the platform with FPGAs. But in studying that, you know, this is actually part of the interesting aspect of the open source. It's not below the level of that, but there's, you start looking at the ecosystem that already exists. A company called Enjoy Digital has a platform called Litex, which uses something called MyGen, which is a Python-like. It's not high-level synthesis. It's hardware. It's synthesis, but it's Pythonic, so it's easy to develop. It's easier for software guys to develop hardware, I think. So that whole aspect kind of opened my eyes to, a lot of interesting work going on, accessing FPGAs with a new layer of tools that those people developing those type of tools, they don't want to deal with different vendors tool sets. They want the whole open source tool chain below them. So if you want to enable people to develop interesting ways to implement or use FPGAs, you're going to need that. It's kind of a prerequisite is to have that open source tools below it. So interesting stuff is up at the top.
So let me come back to the tool chain point, but I'm just wondering, so Professor Betz, I think at Toronto, the professors around you, I think would have a viewpoint on what we're talking about right now, right? You and Professor Chow and adding special features and processors and FPGAs.
Professor Anderson. So
Yes,
that's,
yes.
It's ABC. It's easy. We're we're the ABCs of FPGAs. You could say. So depending on who's, when I'm on a thesis defense committee with Professor Anderson, we always go in alphabetical order. And with Professor Chow, I always suggest reverse alphabetical order. So it works out well. But what exactly is the question? So, sorry, I went off on a digression. So
That's okay. That's okay. I mean, it is the wine, but we had that paper in 2004, and I actually remember that paper about how to take a processor and add custom instructions to it. And I was just wondering, which Ted was responding to, about the analogies in the FPGA space about, do we see open source methods enabling that to a greater degree, having a greater variety of, perhaps the same number of FPGA platforms, but each of the platforms has a larger variety of products in it with custom features, or the FPGA equivalent of custom instructions, which for us would be custom blocks. And I went to you because there's a mix of people at Toronto working at what I would view as kind of somewhat related things.
So I guess the way I think this maybe is on point, but you can tell me if I missed the point, is open source is most powerful when things connect. Okay. And so I'm an academic now, and that's always one of the things that I'm trying to get my students to do is to connect their tools to other ones or work within some existing infrastructure if they can. Maybe it's a completely novel tool and it should invent its own infrastructure, but in that case, you should think of how it connects to others, because that's what gives you complete tool chains and some interoperability. So as a community, I think that's something to just think about. It's long, kind of hard work. If we have a lot of point tools that don't talk to each other, then we wind up with, I think, some good research, but it's much harder to build on because they're all kind of point islands. And one of the things that I think is interesting about, for example, Open FPGA is it creates an open implementation technology that connects to VTR as your place and route technology, which connects to YOSYS as your synthesis technology. And the union of that is more powerful because you can do more, right? So now if you have a vision of some unique hardware or software, you can realize that vision. And I don't have a perfect recipe forward, but I think there are many places where if you can get stable interfaces, we take the GCC example, the fact that it's not that hard to reverse engineer an instruction set, or often it was documented, made it easier for them to target various processors because you could figure out what the processor did. Commercial FPGAs are much harder, right? The bit streams are closed format. They're also much more complex. So just figuring out what the data format to describe that is much harder. Then generally it's also not open. So you'd have to reverse engineer it. So that's really hard. So one path forward is to kind of come up with APIs, and this is happening some, certainly Chris can speak to that, to allow you into those flows. But another piece of it, I think, is entirely open flows that can just bypass it. You got a unique idea and you'll go through a completely open flow. I think we can do this at many different levels, right? We've heard a lot about yesterday about deep learning and how we need better tools for that. So, and then there's lots of great research going on in that space. It will have more impact if it can be connected. And some of the hard work of that is figuring out what are the right interfaces. And if you could think about LLVM and MLIR,
Right.
while it's very hard to think of those right interfaces, once someone builds momentum, documents them, builds momentum behind them, they can have huge impact. So, you know, what are the places where we can connect together? I guess maybe that's something that I certainly in academia, I think maybe often we don't think enough about, because it's not our primary goal. Our primary goal is do research, train students, publish papers. But if we go that extra step to figure out how can we connect these things together, they can have bigger impact in the long run. So.
Well, I agree with you that part of your comments led me to think of asking Chris next. And I'm wondering, Chris, if you can talk a little bit about what people are using RapidWrite for right now and how you see RapidWrite and its use connecting various approaches.
Sure, yeah, I think Vaughn hit on a good point here. So the Open FPGA project is great for, building a whole cohesive platform going forward from, a virgin new architecture. But we also have a whole industry of existing architectures, right? We have obviously AMD, Intel, Microchip, and many others, right? Rapid Silicon's coming up, but they're all these existing architectures. They're very diverse, and so how do you build an open source tool chain that targets all these different architectures? So one project we have, this is kind of a co-project with RapidWrite. So I'll talk about RapidWrite in a second, but we're AMD is a member of the CHIPS Alliance, and one of the projects that we're driving in the CHIPS Alliance is something called the FPGA interchange format. So this is a project where we're trying to standardize what it takes to build place and route. Building a standardized way to describe what you need in a design to do place and route. And it's done in a very systematic way so that if you're an open source developer writing an open source tool like place and route, if you support and target the interchange format, you only have to target the format and you don't have to target every single device and every single vendor. You can just target this format, and then other tools can populate that format so that you can reduce the workload of the open source developer, right? They can focus more on just supporting a specific format than trying to support all these different architectures. So what we've done with RapidWrite is a open source project from AMD's Xilinx, and we interact directly with the designs and in our tools, Vivado, and we can read and write place and route designs. This is an open source project. We got lots of tutorials, examples on how you can take designs, build unique custom solutions. I mean, one example is last year at FPGA, the best paper award went to a project called RapidStream. And one of the ways, a portion of their flow used RapidWrite to get the best speed up they could for their specific application. They wanted to pull together lots of designs, to leverage the capability of doing parallelism, doing lots of parallel builds, and then stitching them all back together. Well, that stitching process, they found that they could do a lot faster in RapidWrite. So that was one example of where open source allowed them to take advantage of their unique capabilities. So we have in RapidWrite the ability to generate this interchange format. So anyone who supports the interchange format can target all of the current AMD Xilinx devices, and they can do that place and route. It basically dumps out everything you need to do represent a place design, route design, all the device model information, everything you need to do all that, all the detailed information. That's all available.
So as I was listening to that, I was recalling to myself that when I'm working, I use a 30-year-old editor called Vim, which is a descendant of a 50-year-old editor called VI. And so what I'm wondering is, we are in a rapidly changing industry and all the platforms change from time to time. And there's definitely an incentive to end of life certain products. But in the open source world, it dies natural attrition or it lasts forever. do we have an opportunity in open source to extend the longevity of different approaches and different specific systems? And I don't know, Ted, what do you think about that?
So your prompt, I mean, it gave me a definite open source use model. There's people who have industries that stay around forever, and they develop products have to last for 30 years, and they would much rather have complete control over the tool chain rather than keep 50 different archived copies of all the tools from the different vendors they use. So open source tools can play I think can solve a significant problem for the people who want to use things 50 years after they started using them. The other thought, or I think it's important that your prompt makes me think about is are FPGAs really more than just LUTs, maybe RAM and DSP, I think a NOC and some IO, and it doesn't need all the new changes, and so people can be using the same thing, and that same thing just gets better and better over time. That would be probably what most of the customers of FPGAs might want. Whereas you have vendors all trying to come up with new features, custom, you get some new angle, some new market, and I don't know if that's a net value add to the industry or not. Whether industry somehow just focus on what FPGA does provide. I think it's what I mentioned,
Right.
Logic, memory, IO.
So Professor Betz, you've been working on VPR and now VTR since the late 90s, and I'm wondering, this point about longevity, how would you take that?
I think it's hard to rewrite all your software. So I think certain open source projects build momentum. As you said, G++, GCC have been around a long time too. And they build a community and a use base. And so there's a reason that they kind of keep going. And I guess I guess I'd agree with that. They tend to have a long lifetime. They do need, constant maintenance and update to keep up with the fact that we're in an industry where the hardware changes and the scale changes. So I don't think we're quite like VI, where you could find something that, if the code hasn't, I use VI as well, but my documents aren't getting exponentially bigger, right? So that makes it easier to keep using VI. I'm going to go back to my earlier comments, maybe state them in slightly different way. Open source gives the potential, I think, for our industry to disaggregate some. We're a very vertically integrated industry.
Okay.
Where we have hardware, the low-level tools, now usually the synthesis tools, and sometimes the high-level synthesis tools, all, the vendor builds a whole stack to sell their silicon. It makes perfect sense. But it does produce an extremely large barrier to entry and to outside innovation. You can plug into that by making new tools above that or beside that, connecting them up to the vendor tools, using certain interfaces, like HDL is a stable interface. So we have innovation in that. I guess I see, as we have this more diverse community of open source tools, that a way to think of it is disaggregation. And I guess if we can build some more stable APIs that go between those tools, go between vendors, it gives more opportunity for someone to come up. I have a new idea for a piece of hardware or for a piece of software in that flow to get it in there without an overwhelming engineering investment. So I think open source helps that. I think trying to create APIs like this FPGA interface format, particularly if they go cross vendor, helps further.
Yeah, I would like to come back to the cross vendor point, but I'd like to ask PE, does he envision himself supporting Open FPGA 30 years from now?
Well, you made a point about retirement dates. So I'll probably still be working 30 years from now. So maybe. But one thing that is important in that context about open source is empowering users. If there is a specific feature in a toolchain, you want to support a legacy product or whatever, as you're a company, you want to support a legacy product, you are free to do so, right? You have an incentive to do so, and you can do that and maintaining that specific part of the code in an open source project. which may not be of the interest of some other companies, right? But you can disaggregate also the maintenance aspect of it, not only creating different companies that will handle different parts of the tool chain, but really creating this broader set of users that will maintain various parts of tools. So now this is true that if you think about an open source project, well, you kind of need somewhat of a lead, right, to maintain the cohesiveness of the infrastructure. We've seen that with VPR now with Vaughn for so many years. Thank you for that. But more and more users are coming there and taking some ownership and some portion, right? And that's, I think, the power of open source.
One analogy or question I'd like to ask is that we were talking about disaggregation and perhaps adjacent to that is partial freedom from specific platforms. In the GNU Linux community, there was a tool that was assembled, a very forgettable tool, but very important tool called AutoConf, which would allow you to sort of generalize the platform support. And I'm wondering, do we think that will open source methods allow us to get towards a state where there's some sort of generic FPGA target, just like AutoConf allowed us to have a generic C source code target? And I'm wondering, is that a clear question? I'm wondering, Chris, does that make sense to a rapid write user? I mean, it's very tied into Xilinx.
So I think, are you trying to talk to the cross-platform or cross?
Or the I mean, I like the additional steps that a rapid write allows you to take, but there's also a cross-platform interest as well, which is what I'm more pursuing right now.
Right. I mean, I think we have to recognize that, you know, if you you're going to steer that thing towards a particular architecture. Am I going to work with Intel FPGAs? Which one? There's hundreds, right? You've got to choose one of those devices. So we kind of need abstraction layers to pull ourselves back so that, you know, we don't have to think so much about all the nitty-gritty details. I mean, that's one of the efforts we're trying to do with this FPGA interchange is kind of taking a step back. I mean, even with, if you're just going to target AMD Xilinx devices, right? Are you going to target Series 7 devices, UltraScale Plus, Versal? They're all different, right? You have a lot of different complexities in terms of trying to support one architecture over the other. So we have to build these abstraction layers to empower ourselves to get beyond that hump, right? Because there's like Ted was saying, we need that activation energy to get over that hump of making a project successful. Because if it's going to take off, there has to be enough people interested in doing it and committing their time and efforts to making that possible.
So a couple of things occur to me before perhaps opening this up to the audience for further questions. And one thing I wonder is, occasionally occasionally open source can enable such great collaboration that closed source people end up pursuing what the open source people are doing. We come closest to that in what I've personally observed, in what Linux can do in the data center. So I'm wondering, is there one possible future is that open source based tools and FPGAs will always scramble to catch up with commercial performance and features. But is there a segment of the market in which commercial FPGA vendors will scramble to keep up with those things that are enabled by collaboration? What would that segment of the market be? I'm wondering, PE, you must have thought about this.
Yeah, I have an interesting view on that. Prior to doing OpenFPGA, I've had the pleasure to do some designs on FPGAs, commercial designs, and user application type of thing. For small application, medical-based, companies, what is the biggest problem? Support. You get none, right? If you're not promising to buy enough parts, you get zero support. And when you have
some issues with the tool chain or bug or whatever that is, right? You're alone, right? And you need to find your way around, problem and issues, browsing through the forum of, the FPGA vendors. With an open source tool chain, you have full control. Not only you can go and look what the problems are, we can imagine also business model where some company will sell supports, generic support for, for various targets using open source tooling. And we all know that having an efficient support is costing enormous amount of money to do that. So I personally think that, all the aspect in customer support, smaller volume, all that kind of thing will have a very interesting business model that is very hard to catch up for bigger players.
And Ted, would you like to follow up on the support issue?
Not particularly. There's a number of issues that are that open source tooling would solve. Support is definitely one of them. I just wanted to comment that as far as this flame analogy, I think so open source tooling is a solution to the problem. But we had last time I was here, Microsoft was definitely promoting, and everyone was excited about FPGAs in the data center. When I think about when I think about open source, I actually think about disruptive technologies, something that can make something grow 10x. And it's not necessarily the FPGA companies that grow, but some industry grows 10x. And I think RISC-V is going to become a kind of a 10x thing. It's going to enable innovation in hardware, because they basically took the getting the processor out of the expense or the decision process. You can just get a RISC-V and you can do your innovation. So it's going to enable innovation, but can the FPGA usage just explode, grow exponentially? So I think Microsoft was trying to push that. I think they were clearly they had it, all throughout their data centers, their hyperscalers. But I think they wanted the other hyperscalers to follow along, so FPGAs would be persistent, and Google, AWS, everything would have. Anyone writing software knows that there's all this FPGA capability there for them to target their software. And I think the question I have is, I think that effort, that push happened, and I don't think it, we made it over the hill. So do we need to keep pushing at that angle? And like I said, open source is definitely one of the reasons we may have failed, is because there was no open source tooling, not just tooling, but maybe all the way down to the silicon. But once all that's there, is there still a use case exists that the data centers become more productive and more valuable because there's FPGAs everywhere? But
to continue that, I mean, one of the potential outcomes of open source is portions of FPGAs become commoditized and the locus of innovation moves higher in the chain. Now, Chris, when you were working in Rapid Write, those are people that want to take Windows into the Xilinx software, and they really want to push it. They really want to go beyond, and they want to control this or that. I think in the support thing, we're talking perhaps a little bit more about plain vanilla use cases, but I think those might converge at some point. Do you see that happening, or is that a pipe dream?
Yeah, I think, well, maybe I'll push back a little bit. Hopefully people use our tools. It's not an echo chamber of nothing. You can get support. People will help you. Maybe there's a stereotype of that. You can email me.
Excellent. Will do.
I will get you that help.
Well played.
The Elon Musk of AMD.
So, I think, yeah, so engineers, Tim's not here with us tonight, but something he would always say is, an engineer would much rather have, not to have to go talk to somebody to get help. If they are empowered to solve a problem themselves, they would like to do so, right? And if that empowering requires them, a lawyer, that's also less, that's not an efficient path as well. So I think giving enough access, enough capability, enough openness that allows them to solve their problem immediately is the best form of support that you can give, right? Because they're just empowered. It's the most efficient way. And open source is a great way to make that happen. I mean, we've been pushing RapidWrite in that direction to making it open and available so that people can have that ability to solve their own problems. Now, dumping a huge code base on somebody isn't always the most helpful thing. I mean, there are engineers who could probably crawl it and get their work done, right? But not everyone has that capacity to take a giant open source project and, if the tool fails, go and find the spot and fix it. Some people can do that, but not everyone can. And so there's a gradient, right? So depending on who you're talking to or who's working on the project, this is kind of something you have to navigate and providing that level of support in those different areas. So open source is just one extra avenue that I think enables that.
So I'd like to point out that we are open to questions from the audience. I see some expectant looks. So if there are some questions, we're all available right here. Oh, and there is the portable microphone is right there. Great. Thank you.
Hello. Oh, hi. Thank you. So to come back to the Hall of Fame paper and the RISC-V custom function units and custom extensions, just a commercial. A bunch of us RISC-V soft processor developers have been talking on and off for several years about common profiles and common standards so that we can have RISC-V soft processor ecosystems across vendors. One of the sub-problems is the FCCM application of soft processors where you add domain-specific custom instructions and custom extensions for your problem. And we saw that across all of the different RISC-V soft processors that have emerged, there's no common way for me to build a custom function unit with custom instructions that works with this soft processor and this one and this one and this one across vendors and across implementations. So we have developed a specification, it's about 50 pages, which introduces interop interfaces for both the electrical logic interface level of composing my custom function units and yours in a system, so that you can have multiple accelerated software libraries and their hardware accelerators in the same system. You can mix and match them and have a marketplace of them. So there's one proposed interface at the hardware software layer so that you can have an unlimited number of custom function unit accelerated hardware blocks that all cooperatively share the same opcode space. So it addresses RISC-V ecosystems opcode space collision problem by adding an interface multiplexing mechanism so that every extension gets the full custom opcode space and there's no running out. There's an infinite number of these you can have. And then one layer down is the electrical specifications for how custom function units can gluelessly compose in a system. If you'd like more information on this, there's a link on my website,
So,
fpga.org.
Do you kind of view this as a kind of a model for what feature collaboration might look like in FPGAs?
That's a little too strong. For the limited domain of RISC-V composition of custom extensions, I think it's appropriate there. And we've scoped it to a certain category of tightly coupled accelerators rather than the entire problem space of accelerators of all kinds. So over time, we hope, so this does give you a kind of watering hole of ways that you can mix and match different people's work and they can build on each other. Anyway, that was the commercial.
Yeah, so the commercial the guy back there twisted my arm, caught me before you did, but you're Jan, great, right? Yeah, so, I mean, I met you, you've been to a lot of the RISC-V summits, so going way back. I know Guy's probably been to one of the early ones, but yeah, I'm definitely interested in what you're doing, not only with RISC-V, but with FPGAs. I was just talking about, can you make, is what you guys trying to do, build a general purpose machine that then is, on FPGAs, then is super powerful, and then software people can know and access. And if that's built on RISC-V, which I think is obviously the right platform, RISC-V or something like that. But Guy talk to me. I'm definitely interested in helping you with the works with the RISC-V International. But I am more interested in is have you come up with a general purpose machine, a paradigm for using FPGAs to accelerate compute for the world, not just a few people who are geeks who want to try something, but actually improve compute. And I think what you're doing, a lot of people are building chips that kind of look like what you're doing. So you look at Esperanto, an array of vector processors. So I think what you're trying to do is an array of processors inside an FPGA that then is more powerful because you can change what it's doing in real time. So it's definitely interesting project.
So right now we have the ability in VTR that we can describe various new blocks in XML. And then those blocks don't compete for descriptive space. XML can be as long as we need. It's not like a custom instruction competing for code space in the ISA. But ultimately, those custom blocks will compete for space in any particular physical chip. The way that we collaborate now, describing features through XML, is that the way to go forward? Are we going to need an additional ways of describing new computational techniques in what they're, I'm trying to, extrapolate from what they're doing in RISC-V here. So I'm going to ask either Professor Betz or PE to respond.
I guess I don't consider the data input format like a sort of a fundamental thing. So picked XML as the architecture description format and extend it in various ways, but you could have a C++ API as well, or whatever you'd like. I think you wanted a decoupling of what is your like a various input layers, basically. And we already have some of that. We'll probably have more of that in the future. I don't know if that answers your question or not, but I try to decouple your internal database representation from what is the input format as much as you can.
Yeah, in the long tradition of FPGA panel sessions, I want to interrupt the love fest. So the question I'm going to ask, I will first ask and then explain why I'm asking it. Okay, and it's directed at anybody who wants to answer it on the panel. And the question is, are we done innovating on FPGAs? Because the reason I ask that question is, if you look at the scenarios that we brought up, which are GCC and Linux, their value proposition was stability. And I programmed in C in 1987, and I'm still writing what looks like C code, right? Those things haven't changed. And the thing that what open source does a great job of is removing rent collection from technologies that are foundational. But it as an artifact of that generally has a tendency to solidify that technology and remove its ability to change. I think one exception to that might be RISC-V, because in some sense it's defining an interface between hardware and software that enables both to still innovate on both sides of that interface. But I don't see that in Open FPGA. So the question is, are we done innovating on, and we don't have that kind of RISC-V interface between hardware and software to work from yet. Unfortunately, maybe that's our fault in this community. So are we done innovating on FPGA fabrics and devices?
So let me take that to the panel, and who wants to speak up?
I wanted to answer when he was 3 minutes in. So, or sorry, 3 words in. Sorry, it wasn't 3 minutes. No, I don't think so. And actually, so I have an alternative viewpoint of this. So if you take G++, it removed barriers to entry. All right. So you could now look inside the compiler, you could innovate on the compiler because it wasn't hidden inside a company. And then you could innovate on, well, what about vector instructions? Could you auto vectorize? And then if we move away from G++ to LLVM, which actually defines some really nice interfaces, you look at all the innovation that's happened in compiler formats and then MLIR and moving it up and so on. I'd actually say there's a huge amount of innovation that's been unlocked by open source in the compiler world. I think it actually led to things like RISC-V of opening up the processor. So making a completely open instruction set then became a feasible and productive project, which then allowed another wave of innovation of how can you change that processor, but probably even more fundamentally, what can you put it in, right? Where you could build systems around it. So I think that's the model. I think Intel and AMD and Microchip and Lattice will do great jobs of building vertically integrated FPGAs that go after their target markets with highly tuned fabrics. Okay, so I think that's going to continue to be true. Where they are not going to be able to do everything, that it just will be outside their purview. They won't have the ideas. It won't fit in their business model. Or innovative SoCs for the following, some custom manufacturing technology that is high risk or strange, some medical device that is small and needs to be reliable. And that's where getting the barrier to entry lower allows you to innovate in those systems. But you have to accept that I think that a lot of your innovation is going to be in the system or a unique underlying technology, et cetera. It's not going to be, I want to do exactly what the giant FPGA companies have been doing for many years, but I'll do it better. And I guess I'm in an unusual position of, I created VPR. It was somewhat open at first, right? But we put a proviso on it of can use it for commercial purposes. Then we commercialized it, actually worked on it inside Altera. It became a commercial version, went back outside, and and I'd actually put a rider in there, like of when we were acquired, Jonathan and I agreed that I would not open source VPR further so long as I worked at Altera. And for 6 months after, and 6 months and a day after I left Altera is when VTR went open source, right? Which it wasn't underhanded. It was basically completely negotiated. So I in those years in Altera, we worked hard on Fabric. People worked hard on the Fabric for years after. I think if with far fewer resources, you say, I will just do that better. That's a difficult thing. But there are lots of gaps in the vision of these companies. They can't know everything and they can't know all the systems. That's where I think the innovation gets unlocked by open source, or one of the areas. Maybe there are others too.
So Chris, I want to bring this back to you because you're basically building a new portal into the Xilinx tools, a new way to use them, a whole bunch of scripting on top of that. And you're opening this up, but you're also enabling customers to do their own innovation on top of what you're doing. So you're moving the locus of innovation. And I wonder, can you elaborate on that?
Yeah, I think FPGAs aren't dead yet. I think we can build just really great FPGA architectures. What I think we struggle with is getting the right kind of software for everybody's needs. I think that's where we have a struggle. I mean, we can build some generic tools that provide a level of support and solutions for everyone, right? Because FPGAs are used in so many diverse markets and applications. We have to build tools that support all of those situations. But I think we need to raise the ability for people to come in and say, okay, here's my application. I can see where this can go 3 times faster, 5 times faster, 10 times faster. If I can do this, this, and this, I need to be able to have that power, that customer. We need to enable those customers with that ability to take advantage and seize the opportunity. And that's all about opening up the software and being able to build on that imagination of those people in the applications who know best what they're trying to implement. Because the silicon's there, we've had it, it's been there. It's just building that software stack to meet our imagination. That's where the biggest challenge has been.
Now, PE
Can
last,
I ask you the
oh, go
question
for it, go
back?
for it.
So what do you think? Have FPGAs stopped innovating or don't need? That's, I mean,
You're just churning the water.
I mean,
I think Herman should come up here. I'm gonna go drink his wine over there.
so Microchip's innovating. I don't know about the other guys.
So PE, last Sunday afternoon, you ran a session with Ganesh Gore about Open FPGA. And you know what Open FPGA tries to do, in my personal opinion, I think is probably one of the things that's the most difficult to make open. And so you watched dozens of panelists interact with what you guys have created. So to the point, you know, that Herman is asking, and which Chris just responded, you know, where do you, when you look at their reactions, and that's a part of the future, where do you see that going?
Well, yeah, I see that as an so it's very interesting. You know, a lot of people using that to me is really an enabler. It's going to enable them to innovate. So we're back to this question, you know, are FPGAs architecture innovation dead? No, it's not. And actually, let me say something that very few people know about Open FPGA. Open FPGA was created initially because we wanted to build a resistive RAM-based FPGA 10 years ago. And how do you get that done? You have to build the entire silicon, you have to build the entire tool chain, you have to build everything. That's what we did initially. And then at some point we realized, well, this is great. Actually, maybe we can also do that for regular SRAM-based FPGAs. That's what became Open FPGA. So in fact, having an open source framework that helps you innovate is going to demultiply, in my opinion, innovation in our field. And that's really one of the things that I've been very pleased to see on Sunday, yesterday, is a lot of people starting to interact with the tool and potentially at some point owning part of the tool and using that for their own innovation. And this is, I think, what is very important and interesting about open source.
Okay, guys, so we've hit the bottom of the hour. Do we have other questions or shall we retire? Oh, Hamish, go for it.
Thank you, Dana. This might be a minority opinion, so let's see how it goes. Someone once said that the EDA industry was all about selling tools to customers, those customers using those tools and extending them in ways that enabled them to innovate. And the CAD vendors would then look at those customizations and bring them back into their tools and sell them back to those customers, right? So in some ways, I think this discussion is maybe not broad enough. I think the GCC analogy is very apt. However, I would look at it broader. I would think the EDA industry is probably more vulnerable to open source than the tightly bound FPGA companies with their proprietary architectures and tool sets. And to go back to Pierre and Ganesh's excellent tutorial yesterday, they didn't get to the architectural physical synthesis. And I think that's actually the crux of open source. And that's probably the place that, in my view, we should be focusing. I'd open it up. And speaking as an FPGA vendor, builder, that's what I see internally as our biggest challenge is how do we crank out more FPGAs faster?
So before I turn it over to the panel, I just want to point out one thing. When I introduced the GCC example, I did mention that all the other commercial compiler vendors were still active. You used the word vulnerable. So I'm wondering, I mean, is it, you know, more of a situation where everybody wins? But let me turn this over to PE and Professor Betz first.
It's true that, some innovation coming from open source might shake the ecosystem, right? And change the way we approach the design of FPGAs. You were mentioning about the physical design aspect of that, right? Reduce time to market, lower NREs, all that kind of stuff. So that's really what we're pursuing here, right? And it can have a tremendous impact on how we have been doing things for a very long time. So that's part of the innovation. It's part of things that can change. That might be a business model for just pure tooling, right? So the EDA part of it can be strongly impacted. One thing that is for sure is that it opens new grounds, and we'll have to see where it goes.
Vaughn?
Yeah, I think what Open FPGA does is really interesting, because it greatly reduces that barrier to physical design. So again, I was at Altera for many years, and the way we were set up is we had some custom tooling to help us with physical design. But there was a lot of manual effort to get a highly optimized fabric. And, these were economically rational decisions, right? We could spend a lot of money on our NRE to get a highly optimized fabric, but it affected the whole way the company thought. Unique high risk SOC, that doesn't really make sense, right? It's too expensive. And it wasn't really in the company's DNA to understand, some new SOC that was emerging to really put what is needed by the customers around the programmable fabric, and then optimize that fabric a lot. So I think greatly reducing that barrier to physical design enables this different model of I can go after more unique opportunities. My skill set is more in the SOC, which at least at that time was not this key skill set of the FPGA companies. And I think you can never have one company that understands all systems. So I think they can't be everything to everyone. So yeah, I think it is very interesting. It does mean that I think if you're trying to build the world's biggest FPGA, well, then it's going to be difficult, right? Because it's economically rational to throw an army of people at optimizing that. If you're trying to build a unique SOC, a unique fabric, it enables that in a way that Altera, at least, we would just walk away from that. That's too risky, too expensive, not a proven market. We don't understand it. Doesn't make sense for us. But I think for a hungry startup that's coming from that market, it does make sense. And I see that all the time in VTR as well. Companies that I don't even know about will send in a bug report saying, we're using this CAD tool for our custom thing that is inside our SOC, and we'd like this feature. I didn't even know they were using it, but it's greatly reduced their barrier to entry for something that incorporates FPGA technology, but is not just a vanilla FPGA. Yeah.
Well, I think we can continue this a little more. I mean, Chris, when you're working with Rapid Write, you're enabling people to do things that in part bypass physical design, physical optimization, final detailed placement, final routing decisions. But, you're enabling people to do things that would not otherwise happen. And all the developers inside Xilinx, inside AMD that do that stuff, it's not like a job is being affected. You're enabling new things that would not otherwise happen. That's my external impression. Is that what you see?
Yeah, I mean, we want to empower people that you see a solution, we'll help you build that solution, right? We'll give you the tools. We want that to be an opportunity. We don't want that to be, that's not even an option. So, making that available, I think, is something that we want to do. Trying to follow this thread, though, I think we were talking about the hardware development, right? Because I think what's happened over, the decades for FPGAs, most of the money is made on the silicon, right? So when you build a new FPGA, you optimize like crazy that area you're going to use, because that's what people are going to pay for. People are going to try to get the smallest part, cram as much functionality into that part as possible. So you want to make that you want to spend that silicon in the most effective, efficient way. So we've had a couple of decades where that has been the market pressure. And I think, that leads to more, you make a trade-off, right? When you make something more complex in silicon, where does that complexity get handled? It gets handled in the software. So I think open source is a way to, you've built this incredibly complex fabric with all these innovations, but the software, it's hard to build that stack up so that you can unlock all that potential. And so I think that's where open sourcing, opening things up, making it more available, enables more of that innovation to be realized.
And just as a selfish follow-up, I've been personally involved in 3 different FPGA assembly systems. I'd rather not do it again. Anyway, it's past 8:30 and we have a last, oh, sorry, go ahead.
Andrew's got one more.
Okay, last question or two from the floor?
All right, this is very much the last question, but my very first FPGA back in 2008, the best panel, because they invited somebody from NVIDIA, a GPU guy, to come and tell us how we were all morons for being like FPGA researchers. And I think what I love about these panels, what I love about this session is this chance to actually have an honest, discussion in the community. So first of all, love the quote about GPT-3, Chat GPT. That's entirely generated on GPUs, not FPGA involved. Like that sucks. That hurts. I think we've seen lots of this where there's all this promise, but what I want to hear from all of you, you've heard of a straw man argument. It's the easy thing to burn down. What's your steel man argument about why we should not do open source FPGA, why we should focus on something else at the least?
Okay, so you're completing Herman's attempt to divert us from the Love Fest. Okay. So I think that since Vaughn has been involved the longest, I will ask him the first.
Well, I think you had a great point about us being out of time, Dana. So I just wanted to hear the question. I didn't actually want to answer it. So you're asking for my straw man argument of
At the very least, why we should focus on something else before we worry about open source.
why we should focus on something else before we worry about open source. I'm just going to answer a different question, that's sort of related, and pretend I'm answering the question, because
You want me to answer it, Vaughn?
that's one of the beauties of being a professor, right? You just answer. Someone asks you a question about X, you answer Y, and you just keep going. But I think it's a bit related. I think open source actually is really important. Now I'm biased because I am working on an open source project, and I have been for a long time. So I guess the straw man argument would be, well, you'll never be as good as the vendors. Right? So why do it? Just accept it as closed source. I think that's probably the best argument of why not do open source. Just as closed, you're in a local optimum, stay there. I don't really buy it. I do believe that there will coexist. I mean, I don't think like Intel and AMD are going to open source their entire software stack anytime soon. And I don't think that the community is going to produce something that outperforms Vaughn and Quartus anytime soon either. Right? They're highly integrated tools, but that doesn't mean you shouldn't do it. The same argument for open roads. So Andreas Olofsson told me he was in charge of the DARPA open road project. And he said, if you stack all the inefficiencies up for the open source projects, it's very significant, right? So he gave me a number, but it's pretty big. And I think this is being recorded. So in case he doesn't want the number out there, I won't say it, but that's not the point, right? The point is to get that flywheel going and to enable innovation that is different than what the big vendors are doing. And I guess I do believe in that, right? We will find good point tools that the vendors will pull back into their offerings. We will find and are finding, unique systems already that can employ FPGA technology. And people are innovating at all levels of the stack. We're seeing tools that are built above what the vendors do. Often the vendors buy them. So, Jason Kong has made multiple tools that have been then subsumed into the vendor stack. Right. So I think there's a bunch of ways that open source and some of those were open to begin with, or at least academic projects. So
Try it. I like that, but also try this. That each one like a one sentence thing. What's your biggest thing that makes you concerned about open source, or where you think this won't work?
Okay, so one sentence. Okay, so biggest thing that then I think the challenge is essentially, I can't get it down to one, but it's two, I guess. Leadership and interoperability, right? The vendors have vertically integrated a very impressive stack. And I think it's beyond any one small group of people to produce such a stack. Where can we find the cut lines to make them talk to each other? And then a related problem is how do we make sure there's some momentum behind those, which is kind of a leadership challenge, which maybe links to the interfaces. You need some leadership to create those interfaces and make multiple tools talk to each other.
I would say openness versus competitive advantage. It's not because you are a strong believer in open source that you need to be fanatic about open source and do everything open source. You need to think what are the pros and cons of putting things open source and potentially keep some portions that will be closed source for, you know, business related questions or maturity levels.
So to your point about GPUs, right? Chat GPT not running on FPGAs. If what we need to enable is the environment in which the next killer application for FPGAs could take hold. That doesn't necessarily mean that we just open source all our tools and just give it to the world. But I think enabling the speed at which we can innovate is the key.
Yeah, I mean, I can. Where the pressure is going to come from, you know, no one at ARM was pushing ARM to switch to RISC-V, right? That's a very hard thing to do. Probably something may happen at some point, but I mean, I didn't know that I didn't recognize you when you're here, but you've got right over there someone at Google. I think if there's something can be shown that FPGAs can be used in a huge scale that haven't been used before. I think it's going to come from, you know, the big vendor is going to be part of that, and they can drive it more than the people who are the big consumers can drive it, or they have the more leverage than people inside the FPGA companies. There's people like me who push on getting. It's hard to push, but it's business. I think is the one word answer.
So I think that open source is built on modern communication technologies, and it allows us to collaborate in new ways. They don't necessarily fully replace the previous ways, but perhaps it's inopportune, but I'll quote Mao, "Let 1,000 flowers bloom."
And I think.
And I'd like to thank the panel.
I thank you for using Windows and PowerPoint to give me that lesson about how awesome Linux is.